I have here a test part I designed for my Delta printer, which is a smoothie board based Boots Industry 2.5 printer that I've retrofitted with a whole bunch of magnetic zero backlash effectors, Chimera hot end, the works. And so today I was doing some testing to see what kind of speeds I could get. And I started with this part. It's a little D that I made that has some of the worst case scenarios. It's got arcs, which would really mess with a Arduino based electronic solution. I've got this little T there, which you can see is asymmetrical, and that's by design. There's a 0.5 millimeter fillet on the right side there, and it's square on the left side to really try to see the ringing effects. This is a 40 millimeter per second part, and you can see it's just about perfect. All the layer alignment that you know, it's hard to see in video, but this is about as good as I've seen. At this whole thing was done at 40 millimeters per second infill, 20% infill, so all of the parts are equivalent, same speed infill and perimeters. So no fancy tricks to do faster infill and slow it down for pretty finish on the outside. So this was the 40. Here's the 60. And when we get to the 60, you start to see just a touch. It's barely noticeable, but you just get a little bit of roughness right there. This is the this arc is the back side of the travel. Looking down on this, it traveled counterclockwise for the outer perimeters. You can see it's pretty much perfect there. Inside is perfect. You see a little bit of the ringing. It's overall, it's not bad at all. It's I would consider this really pretty top quality. This, I'm not exactly sure what's going on there. I haven't researched it yet. I haven't tried changing any settings like coast or something that might affect that. Here's 80. Again, very much the same. You have a little bit of those dots that's kind of hard to see. Smooth on this side. We still have good quality on the little T. We've got the ringing, but yeah, you have a little bit of that weird defect there. Once again, like I said, this part was designed to be challenging to get a perfect surface finish on. This is 100 millimeters per second. You can see now we're starting to get a little bit of a defect on the front side, and then that back side. It's a little worse. We're seeing a little bit of defect on the inside, but still we're getting perfect layer alignment. We have basically, we're not overloading the printer. I did some slow motion video. I might choose to upload it, but it doesn't really show much. It just shows everything moving like it is. So my guess is this is an extrusion issue of some sort, not a motion issue. 120. We still have, beautiful layer alignment. We have the same little back end trailing edge defect there. That's really not that much worse than at 100 or 80. What we're starting to see is now we're getting a little bit of defect in the steady state motion portions, where it's moving around the arc but it's not accelerating or decelerating. So what I would say is I could still use 120 for a proof part, and it would be better than most people's most printers high quality parts, but we really are getting to the part where this is proof only. If I was trying to make something that was perfect, I would probably do a 50 millimeter outside shell and 100mm infill. And then finally, this is 120mm a second again, but I was doing a test to up my acceleration from 2,000 to 3,000, and you can see that it's not focusing as well as I'd like, but you can see that we're still getting the same quality. So that says to me I've been being a little too conservative with my accelerations, but you can see the ringing, and you can even feel a little bit of it. It definitely has a wave that I can feel with my finger, that when we get down to the 60, while you can see the ringing, you can't really feel it in the same way with your fingers that I'm feeling with the 120. That's really all of my parts that I printed and tested, and gives me a good idea of what we can do with our printers.